This is elementary differential and integral calculus, and the question, which is question 20, is a tutorial question drawn from 2020-2021. It reads, differentiate x plus y all squared equals to 5 with respect to x. Now, for us to differentiate this, we note that on the left side we are having x plus y all squared. So bring it out and expand it. So x plus y all squared means x plus y will multiply itself twice. Then how do we expand this? Take this first x here, use it to multiply into the second bracket. Then take your plus y and also multiply it into x plus y. In doing this, we have x squared, then x times y will give us xy, then y times x will give us xy, plus y times y will give us y squared. So in this case, finally we have x squared, then plus xy plus xy will give us 2xy, then we have plus y squared. So this is the value, our x plus y all squared. When it's expanded, it gives us this particular value here. So which means now we can solve this by saying, therefore, instead of writing it as x plus y all squared equals to 5, we're going to replace the x plus y squared with everything we have here. So we can say x squared plus 2xy plus y squared equals to 5. So now what do we do here? What we simply do now is to differentiate, because we asked to differentiate this with respect to x. But note that this is a case of explicit differentiation, okay, or explicit function. I've already treated this before. And you will also bear in mind that this middle term we're having x and y that is multiplying each other. So I will go on ahead to solve this, and with time you understand the concepts I use in solving it, okay? Now let's go here. Now in differentiating 2x, we're going to have, in differentiating x squared, we are going to have 2x, all right? Then plus 2, open bracket. Now since we're having a product here, we are going to apply the product rule. According to the product rule, if I want to differentiate x, I will first of all write y, which is y. Then I will take the derivative of x, which is d of dx. Then we differentiate this, okay? Then plus. Now if I want to differentiate my y, I will first of all write my x. Then I can take the differentiate y. Now take note, this is y function, okay? So I'll put it here as y power 1 minus 1. Then I'll put my dy dx. Then of course I close my big bracket. Then I come to this place. If I want to differentiate this, of course it becomes 2y. Then I'll put my dy upon dx. Everything equals to 0. You notice that if you differentiate a constant, it will give us what? A 0. So this will give us 2x plus 2. Then what we have here, if you differentiate x, it gives us 1. 1 times y will give us y. Then plus, if you differentiate this value here, it's going to give us 1. All right, times x. We have x, then we'll have dy dx in this case. Then plus 2y dy dx equals to 0. Now, in the next step, I'm going to use these two to multiply it into the bracket. So here we have 2x plus, this is 2y, then plus, this is of course 2x dy dx, then plus 2y dy dx equals to 0. So I'm going to move these two terms to this side so that I can, and at the same time, I'm going to factorize out the dy dx. So in doing that, I will have dy dx equals to, this is here, dy dx in bracket here, we have 2x plus 2y, everything equals, you move these two terms to this side, we have minus 2x minus 2y. So in this case now, we have to divide both sides by 2x plus 2y. Okay, if we do that, we're going to have 2x plus 2y. If you cancel this, our dy dx therefore will become, now note here, You notice that we're having minus 2x minus 2y. I can factorize it to be minus 2 into bracket x plus y, and then, pardon me, then we can factorize out this as 2 into x plus y. And in doing this, you will notice here that this will cancel this and this will cancel this. So our final answer will become minus 1.